So today, this is a question from Cengage, however you want to pronounce it, of finding the distance between two skew lines. For reference, distance is the closest point between 2 points or objects. And in this case, the method we're going to use is the equation. So some equation of some plane, that's wrong, plus d over the magnitude of the cross product of two different, well, I'll show you. It's a little confusing just seeing the equation, but basically we just need to find the equation of the plane, and then from there we should be good. Okay, so the first step, we're going to name this one P and Q for clarity's sake. We need to find the normal vectors of these two. So for P, the normal vector is the value attached to, or the coefficient attached to the variable. So that would be 1, 6, and 2. And then for Q of n, it is going to be 2, 14, and 5. And quick reference, if these were in symmetric form, such as equals y minus 3 over 6 equals z over 2, to find the normal vector, it's simply just these values, and the same thing for Q. Okay, so once you have the two normal vectors, you do need to find the cross product, which is found by, taking the cross product, or the determinant if you prefer to use that term. So to find the cross product, if you are unaware, is first for I'm on GoodNotes, so I don't want to mess it up. It'll erase the whole thing. It's weird. So for I, we're going to go 30 minus 28, and the negative 28, it comes from the 14 and the 2, and you always subtract the second term. So attached I hat subtracted by, you always subtract the j variable, or the j hat part of it. So j is going to be the outside corners. So from right to left, the 1 and the 5. So 5 minus, then the bottom left to the top right, 4, j hat. And then for k, it's just the opposite of what I was. So you still go left down, and then the left bottom up. So that would be 14 minus 12k. Okay, so now that we have this, let's just simplify it. It's the 2i minus j plus 2k. So this is, I'm going to erase all this, the solution to the cross product between the normal vectors of P and Q. So now that we have this, we just need to choose two normal points, or not normal, just 2 points in P and Q. And the simplest is always going to be 0, unless of course you end up with 0, 0, 0, which you cannot, and then choose a different value. But for this sake, we're going to do t equals 0, r equals 0. So for P of 0, we are going to be left with 1, 3, 0. And then for Q of 0, we are going to be left with 2, 5, negative 1. Now we just need to find the plane equation, which simply is taking the position of P, of this point P, which is x minus 1, minus the position of y, and these are all coming from P, so these are from here, plus 2 times, and then k is just 0 minus, or z minus 0 equals 0. And then simplifying this, we have 2x minus 2 minus y plus 3 plus 2z minus 0 equals 0, which, simplifying it further, minus y plus 2z plus 1, which may be a little difficult to see this, but this is the reduced form of this. So now that we have the reduced form of the plane, we can plug it into the original equation, which was that the distance was equal to this equation of the plane over the magnitude of the cross product of the two normal vectors, which will be coming from this one, 2 squared plus negative 1 squared plus 2 squared. Okay, and if you're wondering, how do we get rid of the variables for this? That's where the second equation, Q, or the second point Q, comes in. So this will be Let's move this. There's not enough space. Boom. So this will be 4, or 2 times 2 minus 5 plus 2 times negative 1 plus 1 over, this will be 4 plus 1 plus 4. And to preface, make sure you take the absolute value of the top part, because it is distance, and distance, regardless of if it's positive or negative, is still distance. But it's simpler if it's negative. So this will be 4 minus 5 minus 2 plus 1, which is equivalent to negative 1 minus 2 plus 1, which equals 2, negative 2, absolute value. So let's erase all this. So we have the 2, which comes from the absolute value, over, this is going to be equal to square root of 9, which equals 3. So the answer to this equation, or the distance between these two skew lines, is 2 over 3.